Hi all, in this demonstration we're going to demonstrate Cluster Autoscaler. So Kubernetes Cluster Autoscaler is a tool that automatically adjusts the number of nodes in a Kubernetes cluster to handle the workloads. So basically, if we want to draw some simple diagram, let's assume that we have 3 worker nodes. And if you want to schedule 7 pods with node anti-affinity, or based on CPU or memory, it really doesn't matter, but today I'm going to demonstrate with node anti-affinity. So 4 pods cannot be scheduled due to lack of insufficient VMs. So based on that, we can adjust our VMs depending on the workload that is scheduled on Kubernetes. So if we go back to our documentation, please click the Cluster Autoscaler. So it will guide us how to enable Cluster Autoscaler. So it says that, first of all, we need a profile to configuration for Cluster Autoscaler. So in this profile, we are enabling minimum node count, maximum node count, scale downtime, unneeded time. So it says that within 1 minute, if the workload is disappeared, so the VMs will be deprovisioned from our cluster. So let's copy this comment and then pass it to our environment. So we say that new AKS ACI auto cluster profile. We're creating a new profile named ASP1. And if you go back to, again, our documentation, set AKS ACI profile, or we can change the cluster autoscaler profile with set AKS ACI autoscale profile. So I don't have any cluster autoscale profile, so that's why I executed new AKS ACI autoscaler profile. So, and after that, we should enable cluster autoscaler in our existing Kubernetes cluster. But while creating your new target cluster, you can enable by setting up these parameters, enable autoscaler and then autoscaler profile name that we executed a couple of seconds ago. So what we are going to enable on an existing Kubernetes cluster. So what we are going to do is we're going to copy this comment again. So get AKS ACI cluster to list our target cluster and node pools. Right now, I can execute set AKS ACI cluster dash name. Our cluster name is prod CLS. And we are going to enable autoscaler, and autoscaler profile name is ASP1. I'm just going to enable autoscaler. Yes, that's true. It should be. I need to copy. I cannot press the sign button. Boolean. Okay. I need only this. Okay. It will enable our cluster autoscaler, but we should we should enable on node pool level. Right now we enabled on cluster level because node pools can be autoscale enabled. So let's assume that we have 3 node pools. I'm going to just enable autoscaler in the first node pool. I have only 1 node pool right now. Let's wait. So basically, it says that deployment does not have minimum availability on the management cluster. It is spinning up a new pod to manage the cluster autoscaler. If we want to check this one, how it is working, I want to give you a hint. Get a KVA config. It will give me the kubeconfig file of management cluster. Okay, it is enabled. So if we use this config file, kubectl get pods -- kubeconfig on the management cluster, we're going to see that a new pod is spinned up to manage the target cluster workloads. So in case the cluster node pool is not sufficient for the kind of workload, this pod will be charged for to enable the VMs. So it is not sufficient. After that, we should enable on the node pool level. So we have only one node pool. Set AKS ACI cluster node pool enable cluster name. I need to check the parameters. Cluster name, count, VM size, autoscaler. Autoscaler, it should be, let's check that from the documentation again. Set AKS node pool. So basically it's a Boolean parameter. We are not setting up right now the autoscaler profile name. We are going to just enable the autoscaler for Boolean. So every node pool, if you enable the cluster autoscaler, every node pool will be affected by the same profile. I need to have the $sign again. Interestingly, I couldn't type $sign. Yes, I found it. Perfect. We're good to go. 2. Of course, cluster name. Our cluster name is prod-cls, and the node pool name is Linux pool. So basically, we enabled the cluster autoscaler first of all on the cluster level, and after that we enable per node pool level. A couple of seconds later, it's going to be enabled. But this time, let's go and deploy some workloads. And let's go to Azure Kubernetes Essentials GitHub repository and click 01 pods. In 01 pods, we're going to see that node affinity. So basically what we have right now is 2 or 3 nodes in our Kubernetes cluster. kubectl get nodes. Let's check that. We have only 3 nodes, but we have 10 pods needed, and each pod will be scheduled on different nodes. As you can see, required, it's not preferred, and depending on the host name of our work nodes. So let's check that one. And let's deploy it. kubectl apply -f and the YAML file. So if we want to check kubectl get pods, as you can see, some of the pods are in panic state due to lack of kubectl VMs. kubectl describe pod, and then one of the pending mode. So it says that 3 nodes are available, and they cannot schedule, the cluster scheduler cannot schedule the new pods due to that configuration. But our cluster autoscaler is enabled, and a couple of seconds later, the new VMs will be kicked in. So as you can see, the new VMs are kicked in, and are joining into our Kubernetes cluster. So let's check that one. Get nodes again. A couple of seconds later, it's going to be enabled. Our nodes will be appeared in here. Or I can check this like this one. Instead of writing kubectl get post get nodes all the time, what I'm going to do is cp mnt up c Azure user dash kube Azure user dash is this one Azure users Azure user config, then .kube config. Perfect. It is copied. So watch kubectl get nodes. So we're going to observe our cluster within 2 seconds. So every node is scaled. So if we count 1, 2, 3, 4, 5, 6, 7, 7 nodes are joined to our Kubernetes cluster, as you can see from the spinning up type. So within 1 minute, the additional 5 nodes are joined our cluster. So additional kubectl pods, if we execute kubectl get pods, we're going to see some pending pods. The reason is that because of our autoscaler profile, because our autoscaler profile was up to 7 nodes, as you can see. So there are additional 3 VMs is needed. So we can change the profile to 10. By this way, we configure set AKS. Perfect. New autoscaler profile. We created a new autoscaler profile. So depending on that, there's an abnormal behavior. So 7 VMs are spin up, but additional VMs are needed. So I just enabled to 10. So by this way, we can enable cluster autoscaler. Again, within seconds, the new VMs will be joining our cluster. And let's delete the deployment so we can observe within 1 minute to cluster deprovisioning. Cluster autoscaler is deprovisioning the VMs. kubectl get deployment, kubectl delete deployment. There's cache. Okay, watch kubectl get nodes. Within 1 minute, cluster autoscaler will shrink our nodes to 2 nodes because cluster autoscaler profile was the minimum count was 2, and it's sufficient for the basic installation of AKS cluster. So let's wait for roughly 45 seconds, and we're going to observe that the VMs are deprovisioned from Hyper-V environment. Let's count. So basically, this configuration is for unpredictable workloads, or if you want to optimize your costs, both on cloud or on premise, you can enable cluster autoscaler if you cannot predict the workload type, if you have spikes in your environment regularly or seasonal behavior in a day. So you can enable cluster autoscaler, and it is a very highly efficient way to manage the VMs, and it is super fast on Hyper-V environment. Let's wait. and we can observe that the behavior as well from the management cluster. So again, we're going to execute get kva config. So we're going to use this kubectl file to understand what's going on inside the cluster autoscaler. ctl get pods -- kubectl. So if you look at the logs of the cluster autoscaler logs, we're going to copy this cluster autoscaler port in the management cluster. So let's execute this one to understand that was ignoring 5 minutes on removal in the last 5 minutes. So we're going to wait a couple of minutes to, again, cluster to deprovision our VMs. And basically what we have done is, right now, we enabled cluster autoscaler, and after that, the new VMs spinned up. 1, 2, 3, 4, 5, 6, 7, but we have 10. So these pods scheduled on these VMs. So additional 3 is needed. So we enable again cluster autoscaler, and we say that we deleted the deployment. So every pod is deleted from these VMs. So what the minimum count of the nodes was from the cluster autoscaler was 2. So these new freshly created VMs will be deprovisioned from Hyper-V environment, and we're not going to see from the Hyper-V environment and the cluster, Kubernetes cluster. First evolution, not more, may be removed. So it is annotated to be moved. I want to make this video short, so I'm closing, but within a couple of minutes later, it will be deleted, so you can test by yourself. Thank you so much.